All right, this is the 2019 multiple choice section. We're going to try it out. If we make some mistakes, that's okay. We'll just post corrections to it. But we're just going to try it out. So again, this is no calculator, so we just kind of go for it. Number one, we see we have an integral. Since we're dividing by 4, we can always, just take that outside the integral. So we'll have 1/4 times the integral of x squared dx. And at this point, now we get to use the power rule. So power rule means we're going to do 1/4 x to the third over 3 plus c. And then to get the final answer, we just have to do the 1/4 times the divide by 3 to get x to the third over 12 equals c. So that's it for number one. For number two, which is following is the equation of line tangent of y cosine x at x equals pi over 2. So we're going to write down y equals y minus y1 equals m times the quantity x minus x1. So again, we're doing line tangents. That's how we know we want to start with this equation. And now we just kind of throw everything in. So to get m, we have to get the derivative. So y is cosine of x. So to get y prime, we have to take the derivative of cosine, which is negative sine of x. And we're going to plug in this pi over 2. If we do that, y prime at pi over 2 is negative sine of pi over 2. So we know pi over 2 is straight up and down, so y prime is equal to negative 1. All right, so we're still trying to figure out x and y. We know that the slope is 1, but we're given that we want to be at x equals pi over 2. So we want to do minus pi over 2. And our last part we got to figure out is y1. To get y1, we plug pi over 2 into just our regular cosine function. So y equals cosine pi over 2, but cosine of pi over 2 is 0, so we get y equals 0. All right, so I give this our final equation. Y equals, if we distribute, because it looks like they want us to do a little bit of algebra work, negative x plus pi over 2. So I think we're going to get that one. All right, for number 3, we want to take the derivative of this function here, 2 times sine squared of radical x. So this one looks like a mess. So first thing we're going to do is just move the 2 outside. So we're going to have 2 times the derivative of sine of radical x squared. So it looks like this one's going to be a big chain rule. It looks like we got a few different parts to it. So we're going to do it slow and steady with the chain rule, I think. So we're going to say y is equal to u squared, which would mean u has to be sine of the square root of x. All right, so that looks pretty good, but I think we got another chain coming. Because we don't really know square root of x, sine of square root of x. Again, we could use one of our general trig rules if we want. But instead, we're going to write this as u equals sine of v. And over here, we'll say that v is equal to square root of x. Square root of x, we know that one. If we forgot, remember square root of x is x to the 1/2. So we can just use the power rule here. So we get our derivative. V prime is going to be x to the negative 1/2. Because remember, you subtract 1 from the exponent. And we were going to bring that 1/2 out front. So that's what we get for v prime. U prime is going to be the derivative of sine. So the derivative of sine is cosine, so we get cosine of v. And over here, we're going to take the derivative of u squared, which is 2u. So to do the chain rule, remember we multiply all of our derivatives together. So we're going to multiply all 3 of those pieces together. It's going to probably be pretty big, so I'm kind of leaning towards the biggest one, but we'll see what we get. So 2 times 2u times cosine of v times 1/2 times x to the negative 1/2. All right, let's start to simplify things. So we know what u is, and we know what v is. So we get 2 times 2 is 4 times 1/2. Well, those two things will just cancel out. So 2 sine of radical x, because that's u, times cosine of v. V is radical x. X to the negative 1/2 would be divided by a square root of x, and that is in fact the big one, so that is D. So again, big chain rule on that one, but not too bad. You just got to stay calm and just do the chain rule. All right, number 4, we got what looks like a huge integral. So looking like it might be pretty tough. I'm looking at that and I'm thinking, all right, I'm hoping that we can just do a U substitution on this one. Looking at some of the answers, it looks like it'll be a U substitution because we're going from a third power down to a second power on every single answer choice. So I'm going with the U substitution. I'm hoping it works. And I'm going to say U is equal to x cubed plus 3x minus 5. Let's see what we get. Du is equal to 3x squared plus 3 dx. All right, well, we want x squared plus 1, so we're actually pretty close. Because we could rewrite this as du equals, if we take a GCF of 3 out, x squared plus 1 dx. So we're going to divide both sides by 3. So we get 1/3 du is equal to x squared plus 1 dx. That's looking really good because now we can rewrite this integral as 1/3 times the integral. Remember, this is all just going to become du. So we've got 1 over u cubed du. And now it's nice and simple. Now it's just a nice little power rule. So remember, this is u to the negative 3. So we move that up 1. So we're going to go from negative 3 to negative 2. Let me rewrite that real quick. So negative 3 plus 1 is negative 2. Divide by the new exponent. So divide by negative 2 plus c. Then we're going to get, if we multiply the 3 and the negative 2, negative 1/6 times, and u is x cubed plus 3x minus 5 squared. Looks like we got another one down here. Looks like D. Is there a choice E that we can ignore? Nope, but that's what we got. So there we go. Again, I would probably get rid of A and B really quick because you know that you're not going to actually change this bottom at all. So I would probably pick between C and D if I was guessing blind. It does turn out to be D. So there we go. Number 5, function f is given by f of x is 4x cubed minus x to the 4th. And which intervals are we concave up? So concave up means we got to do the second derivative test. So we're just going to have to do 2 derivatives. Luckily, higher order derivatives, not too bad for us. We do really well with derivatives. So power rule here. So 3 times 4 is 12 minus 1. Subtract 1 from 4, we get x to the 3rd. Second derivative, we bring the 2 down, so we get 24x minus just 12. And concave up, we got to find where f double prime is positive. So now we got to find out where this is positive. Easiest thing to do is just set it equal to 0 and make the chart. That way we'll know which sections are positive, which sections are negative. I can take a GCF out of 12, so I'm going to do that, 2x minus 1. I don't really need anything with the 12 here, so 0 equals 2x minus 1. 1 equals 2x. Divide both sides by 2. So 1/2 is going to be our potential critical point. So if we make the table, we got 1/2. It gave us 0. This is going to be x, f double prime of x. If I plug in 0, which is a good choice because that's below 1/2, I can see I'm going to get negative 12. If I plug in 10, I'm going to get 240 minus 12 is way positive. So my positive section where I'm concave up is everything past 1/2. Well, let's see here now. That doesn't make sense because we didn't get any of those as answers. So what did we mess up? I said we were going to mess up. That's okay. So we got to keep calm and see what happened here. Oh, I found it. This x to the 3rd right here. We just dropped it. That's not good. That was very disrespectful for our x to the 3rd. All right, let's fix it then. So that's going to be x squared. So when we do this, we're actually going to get 12x times 2x, not 2x anymore, times 2 minus x. Oh, that's going to change everything. All right, well, it's all right. That's why we double check it. So we get 0 equals 12x. So clearly that's going to be 0 equals x. Over here we get 2 minus x equals 0. If I add x to both sides, we get 2 equals x. All right, same idea though. So x, f double prime of x. So we got 0 and 2. All right, so this problem's going to be a little bit longer than we thought. That's okay. All right, well, between 0 and 2, I think it's pretty clear we're going to pick 1. So I plug 1 in here. That's going to be 12 times 1. So that's positive. If I pick 10, that's going to be 120 times negative 8. So that's a negative. If I pick negative 10, that's negative 120 times 2 minus that. It's going to be 12. So that's going to be negative. All right, so it turns out in this section is where we're positive. So we're positive from 0 to 2. So there we go. So again, messed up. That's okay. That's what we want to do on the test, is just kind of realize, all right, I'm not going to freak out. I'm going to analyze and see what we got to fix. That's a nice one that we can get. We're pretty good, again, at ease derivative questions, so we want to make sure we get these. All right, x plus 3, y to the 1/3 equals y. What is dy dx at the point 2, 8? I see I got y's on both sides. That's a good hint that we just use some implicits to figure this one out. So to do the implicits, remember we just take the derivatives of both sides. Derivative of x is 1, or 1 dx dx, because we're doing dy dx. All right, we got to do 3 times y to the 1/3. So that's going to be 3 times, we bring the 1/3 out front. We subtract 1 from the exponent, and that's a dy dx. For derivative of y, that's just 1 dy dx. So now the plan is pretty straightforward. We just got to do some algebra to get the dy dx by itself. Looks like we're moving this big thing over to the other side. 3 1/3 cancels out, which is nice. So I'm just going to go ahead and subtract y to the negative 2/3 dy dx from both sides. Again, it looks really scary, but it's just doing subtraction. So just like in Algebra 1, we're just subtracting that to the other side. So we get 1 equals 1 dy dx minus y to the negative 2/3 dy dx. We're going to GCF out this dy dx. 1 equals 1 minus y to the negative 2/3 dy dx. Then we're going to divide to get dy dx by itself. And again, we said in class, it's literally the same process for all these questions. So we get 1 over 1 minus y to the negative 2/3 is equal to dy dx. Okay, so let's see what we got. We got a point to plug in. I know we had a point to plug in. We got to plug in 2, 8. Remember, this is the x, that's the y. Our final didn't have any x's in it, so we're just plugging 8 in. All right. So 1 over 1 minus 8 to the negative 2/3 is equal to dy dx. Man, this one feels more like an algebra question than a calculus one, but we carry on. All right, 8 to the negative 2/3. So first thing we're going to do is 8 to the 1/3, or cube root of 8. So that's 1 over 1 minus 8 to the negative 8, 2 to the negative 2. Next thing we're going to do is square this thing. So 1 over 1 minus 4 to the negative 1. And then we're just going to go ahead and flip this. So 1 over 1 minus 1/4. 1 over 3/4 y dx. And that should give us 4/3 equals dy dx. And let's hope we didn't mess 2 of them up in a row. There we go. 4/3 looks like an answer. That's not what we got. That is what we got. That is what we got. All right. So there we go. So it looks like we got D. So again, little implicits. That's how to run it through. For number 7, we're taking this derivative. All right. So this is one that we really don't do in class. Sometimes they throw this on the test. First part's pretty nice. We know that we're taking the derivative of x to the fifth, we got to take the derivative of 5 to the x. So this part we do, like we got that, we're pretty set. 5x to the fourth. Power rule, A is a terrible choice. We get rid of A. Now we got to figure out 5 to the x. All right. Well, we're just going to use our logic skills and know that it's not e to the x. We're not going to pick that one. And it's definitely not a power rule, so we're not picking that one. So we're just left with D. There is a rule that when you got number to the x power, we'll just do ln of that number. If you wanted to see how it works, again, our function, we would set that as y equals 5 to the x, more precisely. 5 to the x equals y. Then what we do is we snail this thing. So we get log base 5 of y is equal to x, but we could rewrite log base 5 of y as ln of y over ln of 5 equals x. And now we can use our implicit skills to take the derivative of both sides. So we get 1 over ln of 5, because that's just a constant. Derivative of ln is y, and that's going to equal 1. Again, this is now dy dx. Then we shift this ln 5 times y over to the other side, so we're going to multiply both sides by that. So we get dy dx equals ln 5 times y. And we know what y is. Y is, oops, not the whole thing, since we just started with 5 to the x. So dy dx equals ln of 5 times 5 to the x. So again, if we wanted to develop it, you do have all of the skills to do it. We typically don't talk about this one, but that's how you would do it if you wanted to verify why it is d. Again, you can always attempt to take the inner rules of all of these. Nice thing is that they don't really work that well. D seems to be the best choice. So anyway, that's number 7. I think somebody might have put that on the midterm also, so kudos if you did that. But we're going to check out number 8. We got to find the limit as x approaches infinity of this function. If we try plugging it in, we see we're going to get infinity over infinity. So this is a L'Hopital question. So if we try to L'Hopital it, again, I'm going to be super precise and write this just because we forgot it on the free response. It is multiple choice, so you can be a little bit lazy. But derivative of the top is negative 12x. Derivative of the bottom is 3e to the x. Because again, derivative of e to the x would be e to the x. We throw infinity in again, and we get negative infinity over infinity. So once again, we L'Hopital it. So we'll take the limit as x approaches infinity of negative 12 over, you guessed it, 3e to the x, because that one still doesn't change. All right, at this point, we can reduce this a little bit to negative 4 over e to the x. And now when we plug this in, we get negative 4 over infinity. And we said anything over infinity, number over infinity gives us a limit of 0. So we're going to take 0 on that one. That's going to head towards 0. We can also think e to the x is going to way beat out x squared. So we're headed towards 0. Bottom's going to be much bigger than the top at infinity. For 9, let R be the region bounded by the graphs y equals 2x and y equals 4x minus x squared. What is the area of R? All right, so let's see what we got here. So we got 2x, so 1, 2, 2, 4, and I'm just going to hope that that's enough. The other equation we have is 4x minus x squared. So let's see. 0 gives us 0. 1, 4 minus 1 is 3. 2, 8 minus 4 is 4. That looks pretty good. So that's enough, because that's our 2 points of connection. So we're just doing the region bounded. So since we're just doing the area, there's no pi's or anything crazy. We're just doing the integral from a to b. of f of x minus g of x dx. So in this case, the higher up function is the red one. So the red one was 4x minus x squared. We have to subtract away the lower one, which was g of x. So we're going to subtract away 2x. And we're meeting here at 0 and 2. So our integral is going to go from 0 to 2. Our dx is still going to be there. This is not too bad of an integral. It's a power rule. I'm going to prefer to simplify at first. So 2x minus x squared. But you can just take the power rule at this point right now if you want. So we power rule it. 2x squared over 2 minus x to the third over 3 from 0 to 2. I don't like those 2's there, so I'm going to go ahead and cancel those 2's out. X squared minus x cubed over 3 from 0 to 2. 0 is clearly going to give us 0, so we get 2 squared minus 2 cubed over 3, which is 4 minus 8 thirds. I don't think they gave it that way. We got to actually do it. So let's see, 4 minus 8 thirds. So this is 12 thirds minus 8 thirds for 4 thirds. And that gives us B. So there we go. So that's what we got for our area for R. All right, for number 10, we got the graph of the function. I moved it over there, which I guess I'm hiding. It's hiding behind me. If g is the function defined by g of x is x squared plus 1 over f of x, what is the value of g prime of 2? All right, so we want to find g prime. So this actually looks pretty nice. This looks like we're dividing. We know how to divide. We're in quotient rule. So g prime of x is low, d high. So that's going to be 2x minus, you can't really see I did the minus over here, but minus high d low, square the bottom, and away we go. All right, so if we plug in 2, we can get some more stuff going. So g prime of 2, f of 2, 2 times 2, minus 2 squared plus 1, times f prime of 2 over f of 2 squared. All right, f of 2 is the first order of business. F of 2 is 3. So 3 times 4 minus 5 times f prime of 2. So that's the slope. Where is a good place for the slope? I guess between here and here. So 1, 2, 3, 4, 5, 6, 7, 8. That was kind of dumb. That's a better choice. Well, whatever. Rise of 8, run of 2, or 4. And we said f of 2 is 3, so we've got 3 squared. All right, that's 12 minus 20 over 9, so that's negative 8 over 9. So there we go. So we got A. So again, we just got to watch what we're doing. Big thing to check out, this is F. It's not G. That's graph of F. So we make sure that we use F for that. 11, let's see, the integral from negative 1 to 1. That looks like a pain, but again, we got that x. So it turns out we can actually go from negative 1 to 1. And it looks like we can just cancel these x's out, right? So we got x minus 1 over x dx. But this one's actually a trick question. So this one's a little bit silly. I'm not really a huge fan of trick questions. But the answer to this one is actually going to be non-existent. And the reason for that is even though it looks like it's pretty easy, we just cancel the x's out and do the power rule. We have to remember from negative 1 to 1, this thing is not continuous. So we're actually not allowed to take the integral of it. So again, the one rule for an integral is we needed our thing to be continuous. We can see that if we try to plug 0 in, it just doesn't work. Yeah, so non-existent. So it just breaks here at 0. So it's not continuous at x equals 0. All right, for number 12. Table above gives selected values for the differentiable function f. In which of the following intervals must there be a number c such that f prime of c equals 2? All right, this looks just like one of the videos that we saw. So we got to find f prime of c to be 2. All right, so we're basically just testing out each of these intervals. So from 0 to 4, we got to see if there must exist an f prime of c. So that's clearly the mean value theorem. So we're going to be using f prime of c is equal to f of b minus f of a over b minus a. Now again, you can probably logic it out and just kind of look at them, but we're going to go through them all to check. So we're going to check a first. So a is from 0 to 4. So that would be 0 minus 8 over 4 minus 0. This is negative 8 over 4. Again, I got the 0, the 8, the 4, the 0. That's negative 2. That's out. All right, next up, from 4 to 8. So if we do that, we got y2 is 2 minus y1 is 0 over x2, 8. x1 is 4. 2 over 4 is a half. All right, let's go from 8 to 12. All right, so here we got 10 minus 2 over 12 minus 8. That's 8 over 4, which is 2. And that's the pick. I'm not even going to bother with D. We wouldn't bother with D anyway. We can see that this is decreasing. That's going to give us a negative for the slope. So there's no point in even trying that one. Same deal with the first one. We really didn't need to try that because it was negative. All right, for 13, we're doing a limit as x approaches 0 of this thing. All right, well, I mean, first thing we do, obviously, we just try to plug it in. So we get 0 over 1 minus 1. That's another L'Hopital if we want. All right, that's fine. We can do L'Hopital again. The limit as x approaches 0. Derivative of sine is cosine. Derivative of e to the x minus 1 is e to the x. All right, we're just going to plug in 0. Cosine of 0 is 1. Cosine of e, or e to the 0, is 1, and we get 1 over 1. So I guess we get 1. I guess we're done. There we go. Next, 14. Particle moves along a straight line. So at time t is greater than or equal to 0, the acceleration is given by a of t is 12t. Time t equals 0, the velocity of the particle is 2, and the position of the particle is 5. Which of the following is an expression for the position of the particle at time t is greater than 0? So we can see that this is a long one. You can see we're in for a bit of work. So I would not blame you if you chose to skip this one on the test and come back to it. But it's not too bad because we are given the acceleration. We are told that a of t is equal to 12t. We can get to the velocity by just taking the integral dt. So the velocity is the integral of 12t dt. The velocity is, the integral of 12t is 12t squared over 2 plus c. So the velocity is 6t squared plus c. Now we're told the velocity of the particle is 2 at time t equals 0. So we know that we're going to get 2 if t is 0. Well, that means that 2 equals c. And so now we know v of t is 6t squared plus 2. Okay, not too bad, because then we can just figure out the position, because now we know, all right, position, s of t, is the integral of v of t dt. So s of t is the integral of 6t squared plus 2 dt. So s of t is going to be 6t to the third over 3 plus 2t plus c. All right, we're also told again that at time t equals 0, the position of the particle is 5. So s of t, well, I guess this is s of 5 now. S of t is 5, so let's get rid of that. So 5 is equal to 2 times 0, 6 divided by 3 is 2, plus 2 times 0 plus c. So 5 is equal to c. So s of t is equal to 2t to the third plus 2t plus 5. Hopefully that's a choice. That looks like a choice right there. Very nice. So we pick D. There we go. So a little bit lengthy, but again, if we stay calm, it's just a bunch of power rules with the integrals. We're good with power rule. All right, 15. Let f be defined above. Which of the following statements about f is true? All right, so we got to choose continuity and differentiability. So for continuity, we check the continuity rules. Hopefully it's not continuous, and then we can just be done with the question, but we'll check. So what we got to do is we got to find out for continuity, 1, does f of 5 exist? Yes, because f, we have to be less than or equal to 5, and we see we've got negative 5 squared plus 3. Negative 25 plus 3 is negative 22. So unfortunately, we've passed step 1. We move on to step 2. Does the limit exist as x approaches 5 of f of x? All right, so that's checking the limit as x approaches 5 from the left of f of x versus the limit as x approaches 5 from the right of f of x. Since this part's continuous, we know from the left we're going to get negative 22 from this part up here. Down here, we still have to plug in 5, so negative 10 times 5 plus 28, and that is negative 22. Negative 50 plus 28. That checks out. 3. Does f of 5 equal the limit as x approaches 5 of f of x? And yes, it does. Negative 22 is equal to negative 22. All right, so we're continuous. We passed all 3 continuity rules. Good, good, not good, neither, not good. All right. Good news is it's continuous. The bad news is the problem continues, because now we have to check differentiability. So to check differentiability, we have to take the derivative of this piecewise function. But that's not bad. We just take the derivative of each part. So we get negative 2x from the power rule if x is less than or equal to 5. Here we get negative 10 if x is greater than 5. So now we need to check all 3 rules again for the derivative. So does f prime of 5 exist? Yeah. That's going to be negative 2 times 5 is negative 10. Does the limit as x approaches 5 of f prime of 5 exist? Yep. Yes, it does. So the limit as x approaches 5 from the left of f of prime of x will equal the limit as x approaches 5 from the right for f prime of x, because we got negative 10 from here. This is always negative 10. Looks like I'm in the way. There we go. So yes, we pass rule 2, and then rule 3. Does f prime of 5 equal the limit as x approaches 5 of f prime of 5? And that is also a yes, because we got negative 10 equals negative 10. So it's everything. It is continuous and differentiable at x equals 5. Passes all 3 rules twice. That's another long problem. All right, 16. dy dx is 2 minus y. If y is 1, when x is 1, then y equals. All right, so it looks like we're trying to figure out our original function. So we're given dy dx. We want to find an original function. Looks like we're probably going to have to do some separation of variables, because we need to get the original function back. So let's go ahead and separate those variables. So I would love to just add y, but then I can't move the dx. So unfortunately, my separation of variables is 1 over 2 minus y. dy is equal to dx. So I have to divide both sides by 2 minus y. And then I'm going to basically multiply both sides by dx. All right. Well, this is not looking like everybody's favorite integral, but it is a u substitution. So u is equal to 2 minus y. U prime is equal to negative y. Nope, negative du. That's not bad then. Okay. So we're going to do the integral of each of these, separation of variables. So we've got 1 over u. We need a negative sign, though, to get du. Turn dy into du. Sorry, I miswrote that. I was thinking the other chain rule. Want to stay consistent. Du equals negative dy. Equals... well, we know this part. We know the integral of dx is just going to be the integral of 1, which is x, so that's not bad. Over here, though, we still got to do this. This is negative, the 1 over u. All right, ln of u. So ln of u equals x plus c. So negative ln of 2 minus y equals x plus c. We don't want that negative sign over there, I think. So ln of 2 minus y equals negative x plus c. Because again, I could do minus c if I want. But let's be honest, it's just a c. So it doesn't really matter what sign we pick for that. We still got to figure out y. So we still have to get y by itself. So to get y by itself, we're going to do e to both sides. 2 minus y equals e to the negative x plus c. Now we said, remember, if we have this plus c up here in the exponent, we can use our exponent rules, e to the negative x, e to the c, and claim that e to the c is just one variable. So we get c e to the negative x. Oops. All right, we still got to get y by itself, so minus 2 on both sides. So we get negative y equals c e to the negative x minus 2. We divide everything by negative 1. Y equals 2 minus or plus c e to the negative x. All right, does anything look like that form? Yeah, they all look like that form. Great. All right, so I'm just going to stick with this because it looks like we got 3 minuses and 1 plus. I'm hoping it's a minus sign. What are we told again? We're told when x equals 1, when y equals 1. All right, so we're going to plug 1 here. 2 minus c e to the negative 1. Okay. Guess we're subtracting that 2 back over here. So negative 1 equals negative c e to the negative 1. Get rid of the negative signs on both sides. 1 equals c e to the negative 1. We're going to multiply by e to the positive 1, because negative 1 plus positive 1 would cancel those out. So e is equal to c. All right. If e is equal to c, y is equal to 2 minus e times e to the negative x. Or e-tricks. All right, that's e to the first. So we go backwards of what we did up here. So it turns out, I guess keeping it like this was the better way to do it, but yeah, that's the way it goes sometimes. I'm allowed to add these two up. So 1 plus negative x is the same as 1 minus x. Is that it? Oh, forgot my minus sign here. So 2 minus 1 minus e to the 1 minus x. And there we go. Man, these last three have been pretty rough. That one's long, and that one's long. I want another one. I want another L'Hopital. So let's see what we got for 17. All right. G is the function given by g of x is equal to the integral from 3 to x of t squared minus 5t minus 14 dt. That's looking pretty good. What's the x-coordinate of the point of inflection? All right, well, point of inflection is when the second derivative is 0 or dne with the sign change. So let's see what we got. So we got to do the first derivative. So g prime of x is the derivative of 3 to x t squared minus 5t minus 14 dt. Easiest integral we're probably going to do because we're just going to cancel those out. And x is just an x, so we don't need to do the chain rule. There's no extra thing to multiply by. We just replace all those t's with x's. 5x minus 14. Again, we could multiply everything by 1 because the derivative of x is 1. No point. G double prime of x. Oh, nice. A little power rule. 2x minus 5. Set this thing equal to 0. Excellent. 2x minus 5. So 5 is equal to 2x. Divide by 2. 5 halves might equal x, but non-existent is not a choice, so I don't even need to check the sign change. We're just going for it. We're going to go with 5 over 2. If you want to be very careful, or if it is free response, you do need to check that there is a sign change. There is no point of inflection, so we know this is the only option we've got. We're going with it. All right, 18 on the derivative. X cubed times secant of 2x. All right. Product rule, because we're multiplying. First times the derivative of the second plus the second times the derivative of the first. All right. Anything we can get rid of right away? Yeah. Hopefully. Maybe. Maybe not. I don't know. Nothing's looking really good right now. Oh, this one looks terrible. I don't like that one. But we actually have to do this derivative. Let's see what we do in the derivative. So let's see, derivative of secant is secant tangent. So x cubed, secant of 2x, tangent of 2x. But we're going to remember with our derivatives, we have to then do a quick little chain here. So we're going to take the derivative of 2x to get 2. Other side stays the same, so plus 2x squared secant of 2x. All right. Is that x squared? So, oh, that's 3. Good thing we caught that. We didn't get tricked. None of them are 2. All right. So that's our final answer. So let's see. We got 2x to the third, secant 2x, tangent 2x, plus 3x squared, secant of 2x. This one, that's the one we go with. Not too bad. So product rule with the trig chain. But again, since we know those trig chain rules, we went over those, that's going to be pretty easy. All right, particle moves along the y-axis. Time t equals 0, we've got the position. Which of the following statements describes the motion of the particle at time t equals 1? All right. So let's see, moving up or moving down, decreasing velocity, increasing velocity. So first thing over here, moving down versus moving up. This is going to be the derivative. So that's going to be y prime. So let's go for that right now. So y prime of t is t squared times 3 minus 2 times 4. T, yep, that's this one right here, plus 4 plus 0. So y prime of t is 3t squared minus 8t plus 4. We want to know what's happening at time t equals 1. So y prime of 1 is 3 times 1 squared minus 8 times 1 plus 4, which is negative 1. So we're going down. So we are moving down. So let's get rid of C and D. Now we have to check the increasing or decreasing velocity. So now we got to find the slope of that. So we're going to do y double prime of t. So that's going to be 2 times 3t minus 8. So y double prime of t, 6t minus 8. Y double prime of 1 is going to be negative 2. All right, so let's see. They used the word velocity and not speed. So we're going down, but our acceleration is negative, so we would be increasing speed, but technically we're decreasing velocity. So velocity is technically going down because it's getting more negative. So I'm going to have to go with A on this one. So we do have decreasing velocity, I believe. So I'm going to go with that one. So we're going to pick that one for 19. All right, for number 20. So we got the integral from 1 to 4 of f of x is 8, and the integral from 1 to 4 of g of x is negative 2. Which of the following cannot be determined from the information given? All right, right away, I'm guessing they're going to make me multiply them, and that's going to be the one. Yeah, that's okay. Easy. But just to double check, to get to A, this is the same thing as negative the integral from 1 to 4 of g of x dx, which we could do. That will give us 2. This one, we can bust the 3 out front. So 3 integral from 1 to 4 of f of x dx is 3 times 8, which is 24. And then d down here, we can actually split these up. We already said that we could do this one. That one was 24. 1 to 4 of g of x is given, so that's plus negative 2. So the only one we can't figure out is c. So we said we're not allowed to multiply. There's no multiplication rule for the integrals. We just have to multiply them out. All right, 21 for any real number. Well, that's definitely the limit definition of a derivative. So this is actually asking us, what is the derivative of sine of 2x? Derivative of sine is cosine. And again, just like that other question, kind of silly they asked it twice to bring that 2 out front. But there we go. Pretty quick. 22. Excellent, a slope field. So we got to find out this is a slope field for which of the differential equations. All right, so let's first see if there's anything suspicious going on, and there is. So when y equals 0, dy dx is 0. This is not always going to be 0 when y equals 0. This doesn't even have y in it, so we'll get rid of that. So we're between c and d. All right, so d says the derivative has the same sign. So this means that the derivative is always positive. Slope is positive. Always. So let's check it out. Do we always have a positive slope? Yes. Okay, so we're picking D. So there we go. And we're all set. Cool. I think we're good. I think we got it. Moving on. For 23, base of the solid in the region in the first quadrant is bounded by the x-axis, the y-axis, the x-axis. The graph y equals e to the x, so e to the 0 is 1, so that's going to look something like this. And the vertical line x equals 1. So that means this is going to be at the point 1 comma e. For this solid, each cross-section perpendicular is a square. What is the volume of the solid? All right, so since we got a square, we're doing the integral from 0 to 1. So I guess we didn't need that e of our equation. Our equation is e to the x. And we have to square it for our formula, dx. Let me write the formula over here. Integral from a to b of f of x squared dx is, if we're doing perpendicular to the x-axis, is a square. We're going up and down with our intervals, so we know we want to use the x's. So that's good. All right, so we actually saw this one, I think, in a homework question, where this is kind of a tricky integral. Unless you remember that you want it to become e to the x and another e to the x, because if we do a u substitution, du is e to the u du, and this integral is actually the integral of, well, we'd have to switch our limits of integration. So it's the integral of e to the u du. Not that. Oh, definitely not that. It's the integral of u du. Our limits change. So 0, e to the 0 is 1. We do get to use that. E to the 1 is e. So we go from 1 to e of u du. Power rule, integral of u is u squared over 2 from 1 to e. So we get e squared over 2 minus 1 squared over 2. That's this one. 1/2 e squared minus 1/2. All right. Perfect. I think that actually was just one of the homework questions. Yeah, I think no, because maybe the homework question had like another little chain to it. Anyway, that's how we do it. It's very similar to one of the homework questions. I think we even did it. So, all right, 24. We have the graph of the piecewise function of the linear function f. What is the value of the integral of 0 to 12 of f prime of x dx? So the idea here is to remember that this integral is going to be f. The integral of f prime is just f, so f of 12 minus f of 0. So that uses the fundamental theorem of calculus, integral from a to b of our function is going to be the value at the upper limit b minus the value at the lower limit a. F of 12, I can't see because it's behind me. -4. F of 0, 4. -8. Excellent. All right, that's all we got to do for that one. So it might look a little bit confusing at first, but again, we want to remember our fundamental theorem of calculus. Equation y equals 2e to 6x minus 5 is a particular solution to which of the following differential equations? All right. Those look kind of tough, but the idea here is we just have to find y prime and see if it works. So that's actually not too bad. So derivative of this. So y prime is equal to, I'm actually going to put that down here. Y prime is equal to e to the 6x. So that's 2 times e to the 6x. Derivative of 6x is 6. Minus 5 is nice. Derivative is 0. So y prime is equal to 12 e to the 6x. So let's see if this works out. So 12 e to the 6x minus 6 times 2 e to the 6x. Because this is what y is, minus 5. So I'm plugging this all in just for the y. Minus 30 equals 0. Come on, work out. All right, 12e to the 6x minus, excellent. We distribute 12e to the 6x plus 30 minus 30 equals 0. We are good to go. I think we got it in one. I'm going to trust that, and I'm going to move on, and I'm going to hope we did that right. All right, for 26. What's the value of x where we have the minimum value from 0 to 1? We see we have a closed interval, so this is going to be a candidates test. So what we need to do is get all the critical points and then also test the endpoints. So we got to get the critical points, so we're going to take the derivative. So that's power rule, 4/3 x to the 1/3, and then minus 2. So y prime is 4x to the 1/3 minus 2. We set that equal to 0. 4x to the 1/3 minus 2. So we add 2 to both sides, 4x to the 1/3. We divide both sides by 4. So 1/2 equals x to the 1/3. And then we cube both sides to get rid of that 1/3. So 1/2 cubed is 1/8 equals x. All right, so our candidates that we've got are not very friendly. So x and then y, we've got 0, we've got 1/8, and we've got 1. All right, I really don't want to plug 1/8 into that equation. So let's just double check to make sure it's actually a minimum first. X f prime of x 0, 1/8, 1. If I plug 0 into here for my derivative, I get -2. If I plug 1 in, that's 2. So negative to positive is a minimum. All right, we got to plug it in. Okay, well, we tried. If I plug 0 in, I'm going to get 0 pretty clearly. If I plug 1 in, that's going to be 3 minus 2 is 1. All right, let's plug in 1/8. So 3 times 1/8 to the 4/3 minus 2 times 1/8. All right, so 1/3 power would be cube root. So that's 3 times 1/2 to the 4th. Minus 2 times 1/8 is 1/4. All right, 1/2 to the 4th would be a 16th. So 3/16 minus 3/4. Okay, that's a negative number. So that is the value of x at which the minimum occurs, because that's going to be negative, and the other ones were 0 and a positive 1. 3/8 is less than, or 3/16 is less than 3/4. All right, a lot of words, but sometimes they're the easiest questions. Time t equals 0, tank's empty, fills with water. Time t is greater than 0, depth of the water is increasing at a rate of w of t feet per hour. So we're increasing at a rate of w of t feet per hour. Best interpretation of w prime of 2 is greater than 3. So if w is feet per hour, w prime is feet per hour squared. So we got to find something that's a feet per hour squared, or the rate is changing. All right. We also know we're doing a derivative. So this is at t equals 2, so at 2 hours. So 2 hours after the tank begins filling with water seems okay. Over the first 2 hours is an integral. That's not good. 2 hours after the tank is okay. Over the first 2 hours is not. That would be either an integral or an average rate of change. So derivative is going to be at a point. All right, depth of the water is increasing at a rate greater than 3 feet per hour. Well, that's wrong, because we said we wanted to have these units. 3 feet per hour. There we go. All right, so we just had to logic that one out. That one is derivative in context. Almost done. Oh, great. I dread this question. So we are 30 feet from point P. Point P, I'm hiding point P. There is point P. And we're going to watch the balloon rise vertically. Luckily, they did the draw step for us. So this is our D for our dreads. So our rate box, we've got that is 30. That's a triangle. What are we trying to find? The balloon is rising at a constant rate of 2 feet per second. What is the rate of change in radians per second of the angle at the instant when the balloon is 40 feet above point P? All right, so we're doing an angle. So d theta dt is going to be our question mark. So let's call this A, B, and C. We might not need everything, but we'll see what we need. So we know that A is 30. So dA dt we don't really need. It would be 0. We're not really moving. B, we have some information about B or C. The balloon is rising at a constant rate of 2 feet per second. So that's dB dt. So that's going to be 2. We're told the instant the balloon is 40 feet above point P. So we know B is equal to 40. All right. So that's all of the information that we've got. So that's our rate box. So somehow we need to relate A, B, and theta. All right. So with A, B, and theta, that would be tangent. So tangent of theta is opposite over adjacent, is B over A. Okay. Great. So tangent of theta is B over A. Well, we got two options. We can either go with the inverse tangent, or we can just go ahead and take some derivatives implicitly. I'm feeling like we should do some implicits here. So never mind, I take that back, because the derivative of tangent would be secant squared. Let's not do that. Let's go ahead and take the inverse tangent of both sides. So theta equals tan inverse of b over a. All right, so now let's take the derivative, because I like the derivative of theta. That's a good derivative. That's d theta dt. That's what we're trying to figure out anyway. Derivative of inverse tangent is going to be 1 over 1 squared plus b over a squared, which I guess the formula doesn't put the squared right here. So 1 plus u squared times du. So we need the derivative of b over a, but the derivative of b over a is going to be 1 over a db dt, because remember, a is constant. So if we think about b over a, again, we could do some crazy stuff, but a is a constant. So the derivative of b over a is the derivative of 1 over a times b. 1 over a is just a number, so it stays in place. Derivative of b is db dt when we do the chain rule. So that's what our u prime would be in the formula. And you could stick this up here if you want. I like putting it off to the side. It looks like we're home free. It looks like all we're doing is substitute and solve. We just plug them in. So d theta dt, oops, it's theta, not a phi, is 1 over 1 plus b over a. So that's 40 over 30 squared times 1 over a. So 1 over 30 times db dt, which is 2. All right. 1 over 1 plus 16 ninths times 1 over 15. All right. We're still going. We're still going. All right. So this is going to be 9 ninths plus 16 ninths is 25 ninths times 1 over 15. So it's 9 over 25 times 15. 3 over 25 times 5. I can't reduce anymore, so I'm picking this one. Yep, 25 times 5 is 125. All right, dreads question. Not much to do but do it as a dreads question. Again, this is one of those, I don't blame you if you skipped it and came back to it. 29, how many vertical asymptotes do we have? So vertical asymptotes, we have to remember that is when the denominator is 0, but the numerator is not 0. So that's kind of weird, because remember, our vertical asymptotes, we have to make sure that the limit does not exist for the vertical asymptote. So for the vertical asymptote, if we check x to the 4th minus 16, we're going to use some algebra skills to split that into x squared minus 4, x squared plus 4. Again, we're just factoring a squared minus b squared. And it's a bonus. We get to do it again. X minus 2, x plus 2, x squared plus 4. So if we write this, we get y equals x minus 2 over x minus 2, x plus 2, x squared plus 4. And then these cancel out. So if you remember all the way back from like the first week of class, when we're taking a limit, this is going to give us a hole. So that's going to be our hole. So that's not an asymptote. Those cancel out. So our asymptote is going to be where this function, after we plug the hole, has an undefined location. If we tried each of them, x plus 2 equals 0, x is equal to negative 2 would be an asymptote. X squared plus 4 equals 0, x squared equals negative 4, x is equal to plus or minus 2i. We do not think about imaginary numbers in terms of asymptotes on a regular graph. We have one asymptote. All right. Last question. For what value of b does the integral from 1 to b of x squared dx equal the limit as n approaches infinity of the sum of k from k equals 1 to n of one quantity 1 plus 2k over n to the second power times 2n? This looks like it might be tough, but this is the key over here. Remember, over here, this is always b minus a divided by n. All right, well, if a is 1, b minus 1 has to be 2. We add 1 to both sides to get 3, and we're all done. Now, it's also possible they could try and trick us. They could say that, oh, I went backwards, but negative 1 is not a choice. So they could have done some weird thing where they flip-flop the integral, but negative 1's not a choice. So that's it. We're all done with number 30. It's just knowing, again, we're knowing that formula. We don't actually have to do this, which is pretty nice. Now, you could if you really wanted to, but we're not going to. All right, so that's all 30. So of the 30, again, once you finished, what you want to do is kind of rate yourself, either easy, medium, or hard. Now that you've seen everything, now that you've looked at all the answers, and when you actually do it, you have to count them up. So the way that you want to count them up, just like on the ACT, all the easies, those are plus 1s. All the mediums, those are plus 1/2. All the hards, those you just want to skip on the test. So you want to be able to identify them and not waste your time on them. Come back to them if you do have time at the end of the test. But again, you only get an hour for all 30 of these questions. You got to do one question every 2 minutes. It is a little bit quick. And then count them up. See how many points that you would get. Again, this is kind of your skills inventory, so you're trying to figure it out. Again, the goal is to get a green score. So if you can get 15 points or more, that's awesome. We want to try and get a green score. Obviously, the more you do, the better you do. On last year's, or I should say on the 2023 test, to get a 5, you needed to get about a 67%. So if you get a score of 20 from this, that means you're headed towards a 5. Again, you can look up all the summary statistics if you want for all the other scores. I just know that one because I got to know that one for all of the tests. So that's the entirety of the thing. Hope it was fun because I had fun.